It gives me great pleasure, firstly, to welcome you all to the second day of our conference and to stand here as your newly elected chairman, and my thanks to the alumni for electing me for the next 2 years. Our next session, to start our next session, I'd like to introduce to you our first scholar who will be speaking this morning, and that is William Atkinson. He is a scholar supported by the Elizabeth Creek Charitable Trust. He's a mixed farmer from Yorkshire, managing an arable area of around 500 hectares. He's a keen sportsman, watching rugby now from the sidelines because he's too delicate to play himself. His topic is around site-specific weed management and is hopefully going to give growers some introduction to how he thinks the future may look going forwards. William.
Good morning. Good morning. I would of course like to start by taking this opportunity to show my appreciation to the Nuffield Trust and everybody involved within it. The Elizabeth Creek Charitable Trust, a Clyde Higgs Scholarship, for being my sponsor, Christine Hill for giving up her free time and editing my report, and of course my family at home for managing without me, which I'm repeatedly now informed doesn't take much managing at all. And of course my fiancée, Kirsty, who is here with me today. So I visited Canada, the US and Australia on a 9-week journey, meeting leaders from research, development and commercial sectors. It is worth pointing out at this point that much of the technology that was witnessed is in a development stage only, and as a result, there wasn't an opportunity to take any personal testaments to the effectiveness of the technology on farm. Now, that said, one of my highlights was visiting Andrew Bates, CEO and founder of Swan Farms in Emerald, Queensland, Australia. He took me to a field where a manned aircraft was broadacre spraying a herbicide onto the stubble, ready for planting later that week. Now, although the pilot would argue with me on this, there was, of course, nothing precise about it at all. Andrew then took me to see a swarm of fully autonomous, self-propelled platforms using photosynthetic cells to precisely spray the spray where only required based on its own decision-making process. Now, of course, the airplane isn't a true representation of today's modern practices, but it was great to see how Andrew, as a farmer, was innovating at the farm level and taking an idea through to realisation. As he put it, the only physical boundary was a rusty old fence line and our imagination thereafter. He had a great analogy. He said, "We tend to use things that are too big, numb and heavy and commonly inaccurate to do the job that often requires something of the complete opposite." He gave an example. When trying to remove a splinter out of our hand, we have a tendency to use a pair of pliers, when in reality, all you need is a pair of tweezers to do the same job with greater accuracy, less cost, energy, and better efficacy overall. But for me, my interest in becoming site-specific started back in 2013. Whilst driving up and down the field, spraying, questioning why I'm spraying everything and not just the weeds. Driving at 12k, trying to control multiple sections, it inevitably led to an overspray and an underspray scenario. Other than the fact that it proved the theory that Yorkshiremen are, as the rumour says, inherently tight, it also made for common sense. 2 years later, I thought I'd found the answer: a drone. I quickly set about finding a system that was available to do the job of flying the fields, taking images of blackgrass growing areas before popping them into a map, into the sprayer, and away I'd go. A whole heap of problems ensued, and I of course found myself thinking it would have just been cheaper spending the money on the sprays in the first place. But nonetheless, the concept was proven in principle, and the image here displays that the savings are there to be had should we be able to successfully identify the difference between the weed and the intended cash crop. But all too often, technology is built around hype and not delivery. The Gardner hype cycle is a great explanation of this. The red line here shows how, on initial release, the technology excitement builds rapidly, normally with the help of a media bomb exploding behind it, before the realization kicks in and we acknowledge we need to get something back from it. I believe we're somewhere around here with weed technology, and before long we may just start to get something back from it. What they have done is helped me fine-tune some of the questions that needed answering. When searching for the right solution for the future, some of the problems listed here were areas that needed to be addressed. Specifically, the last point in green. It's worth pointing out at this point that a drone will typically work to a resolution of around 5 to 10 square centimetres per pixel and a satellite of 60 square centimetres per pixel up over, which is hardly sufficient when you put into context that a blackgrass head is around 6 square millimetres. But what if, instead of using passive technology that comes with all the associated problems discussed there, we could do it all in real time with active sensing like that? And when scaled up to look something like this. This technology not only has the ability to control each individual nozzle, but also change the rate at each individual nozzle from one of 100 different rates per second, as shown here at 0, 25, 50, and 100% rate applications. These were all within 2 meters of one another. Now, admittedly, this video I took in New York, Pennsylvania, in southern Australia of this Agrifax sprayer was using an external data source to create the prescription map for the sprayer to apply to. Although I was able to see some technology working in real time at a research facility in Queensland, where a camera no more than 80 centimetres off the ground with a slight lead on every nozzle fed the information into a computer, deciding whether a spray was or wasn't required. Unfortunately, I wasn't allowed to take any pictures to show you, but if I was to give you a clue, it started with J and ended with on deer, it should enlighten you as to what level this technology has been commercialised at. Here is an example video being taken with a handheld camera whilst being fed into an analysis program, and through using leaf shape recognition or object-based image analysis, they can successfully identify the difference between a cash crop and non-cash crop, along with a percentage of probability. For me, this technology is the only way forward in the short term, with its ability to gain a resolution of just over 1 millimetre per pixel, as well as removing all the associated problems regarding legislation and labour. But this technology is, of course, only as good as the technology we pour out the spray can. And as resistance continues to develop, its shelf life will cease to exist also. But unfortunately, we may not yet get the opportunity to prove this technology before this takes hold. I'm not going to get too bogged down in the saga around glyphosate, being an arable farmer, but its risk of falling only mirrors the risk the industry is feeling right now, and how growing food seems to be becoming the most socially unacceptable industry today. But what it did help me with is to better steer how the remainder of my topic should go. And so I set out looking for some alternatives to chemical solutions, each of which were in theory possible, but none of them were efficient both in efficacy or timeliness as a solution on offer today. For any of the alternatives to succeed, it required a change in mindset of the individual doing the job, with a change in cropping rotations and row widths. These technologies were possible with the aid of inter-row management, along with the required row sensing technology to make it work. My two favourite concepts I saw, however, were Jeremy Weiner from Weed Techniques, Sydney, and Dr. Graham Ian Brodie from the University of Melbourne. Jeremy had designed a water boiling system that turned ambient water to 140 degrees C in a matter of minutes before applying to the intended area through a hooded nozzle body and exposing the weeds to a terminal dose of hot water. Exposure time of less than a second was enough to rupture the cell walls of the plant, leading to its death. Dr. Brodie had designed and built a microwave machine for essentially doing the same thing. But of course, the machine didn't need an external supply of water to boil, but instead heated the water within the plant to create the same outcome. The difference between all the technologies was the amount of energy required to kill the given target. Dr. Michael Walsh of the University of Sydney was keen to point out that the main driver in deciding which route was best to assess is to assess the level of energy required to make each system work. So I was all hung up on this microwave system. And on returning to the UK, I met up with the University of Loughborough to discuss the feasibility of scaling a microwave platform up to 12-metre wide machine. As it turned out, the concept would require more than 30 megawatts. About the size of the power station at Rotherham. And so it may be that ultimately mechanical hoeing may still prevail with its lowest energy requirements of all. But the day when robots are fully commissioned has the ability to change all of this. I'll recall what Andrew Bates said to me at the start of the presentation with regards to pulling the splinter out your hand. Maybe the real answer is where exact applications are applied, whether they be in the form of energy or chemical, and the list of chemicals that then become available once guaranteed applications are guaranteed will also increase exponentially, say for non-selective technology such as glyphosate, for example. The irony in most of these concepts is that one is reliant on the other failing. The chemical industry is relying on the non-chemical industry not becoming more cost-effective, and the non-chemical industry is relying on chemicals being banned to make their system viable. Of course, the reality is there's probably a need for both. So, my take-home messages. Educational arenas seem to be the non-biased arenas of the world, and the biggest blue sky thinking ideas are often created here. Students don't carry the stigma that the traditionalists carry after a number of years' experience in the industry. Possibly here is a great opportunity to find better connections for the future. Legislation continues to push the boundaries of on-farm viability, and as a result, we shouldn't be afraid of attempting to get one step ahead of the social change. But most of all, we shouldn't shy away from it. We should engage, educate, and hopefully, bit by bit, we may just be able to turn the tide on the disconnect between primary production and consumption. Shiny equipment is too often sold on the ability of a salesman or woman and not on the merits of the machine itself. So next time you go and buy your tractor, don't just presume everything's going to be tickety-boom because you've done a deal. And my closing comment would be this. At 2 years old, the brain is 98% imaginative, and by the time we reach 58, it's only 2% imaginative. So maybe we should all reconnect with the inner kid within ourselves.